Here is some help on the interval and radius of convergence practice problems from page 9. I was just going to post the key, so I was sitting here making my key, and I'm like, I'm working out these problems, I might as well videotape it. So the first one's already done, so you can pause and take a look at that. But basically, when you do that ratio test, you end with the limit as n goes to infinity of x over n plus 1, which the denominator is going to infinity, the fraction goes to 0. And remember, these converge as long as your limit is less than 1. And so since 0 is always less than 1, that means we're always going to converge. Okay, how about the next one? So I guess number 2 is below it. To write kind of small here. So let's do the ratio test. So the limit as n goes to infinity of the absolute value of, so that would be n plus 1 factorial times x to the n plus 1 over 2 times n plus 1, all of that factorial. And then divided by, or times, I'm going to go ahead and flip and multiply. 2n factorial over n factorial x to the n. Okay, so equals, way over here. Limit as n goes to infinity. So let's kind of break this down a little bit. So absolute value, the n plus 1 factorial, I'm going to write as n plus 1 times n factorial. And then x to the n times x, for the x to the n plus 1. It'd be like x to the first. Over. So for this, 2 times n plus 1 factorial, we'll need to be a little bit careful. So that would be the same thing as 2n plus 2 factorial. Right, if you distribute the 2, that equals this. So that would be, let's just kind of expand it out. It would be 2n plus 2 times 2n plus 1 times 2n times everything lower than that. So notice I'm starting at plus 2, then plus 1, and man, there's a big shadow right there. Okay, so I have plus 2, then plus 1, and then just 2n, and then everything lower than it. So I'm going to go ahead and put the factorial there with the 2n times, now on the top we had, draw a little line here, 2n factorial, and then over n factorial x to the n. Okay, so we can cancel out the 2n factorial, the n factorial, and the x to the n. So I end up with the limit as n goes to infinity. So on the top, I just have x times n plus 1. On the bottom, I'm going to have this 2n plus 2 times the 2n plus 1. So if I sort of FOIL that out, that would be 4n squared, let's see, plus 2n plus 4n, so plus 6n, and then plus 2. So when we do this limit, remember it's as n goes to infinity, nothing with x. So just do Bobo button with the n's, kind of ignore the x. And this is bigger on bottom. So that means this whole thing would go to 0, because 0 times x is 0. And just like the previous one, with the ratio test, it converges as long as your limit is less than 1. 0 is always less than 1. Therefore, this has an infinite interval of convergence and a radius of convergence of infinity. So there's our answer. Okay, so number 3 over here. Let's set up our ratio test. So the limit as n goes to infinity of, let's see, so we have absolute value of x minus 2 to the n plus 2, because I have to add 1 to the n's, over, whoa, that should not say n plus factorial there. It should say n plus 1. So that's going to become n plus 2 times 4 to the n plus 2. So that's a sub n plus 1 over a sub n. So over the original, x minus 2 to the n plus 1 over n plus 1 times 4 to the n plus 1. So here's what I have. So I need to flip and multiply and reduce, all that. So let's see. Come over here and do that. So the limit as n goes to infinity of. So I have x minus 2 to the n times x minus 2 squared over n plus 2 times 4 to the n times 4 squared. And now I'm going to flip and multiply the bottom. So that would be n plus 1 times 4 to the n times 4 over x minus 2 to the n times x minus 2. My goodness, I'm so sorry. Messy, I'm running out of room here. Okay, so now we'll cancel stuff out. X minus 2 to the n cancels. And let's see, the 4 to the n cancels. But then I can cancel a few more things, like this 4 to the first can cancel with one of these 4s down here to make that just 4 to the first power. And this x minus 2 can cancel with one of these. So I'm really just left with the limit as n goes to infinity of the absolute value of x minus 2 times n plus 1 over n plus 2. And here, doing this limit using Bobo-Botten, the exponents are the same. Remember, I'm looking at the n's because that's the limit as n goes to infinity. So since exponents are the same, when I divide coefficients, I would just get 1 times this x minus 2. So essentially, I just get x minus 2. And remember, to converge, that has to be less than 1. Okay, so what that means is that negative 1 must be less than x minus 2, which must be less than 1. So I have to put that in the middle. Add 2 to everything, and we get 1 is less than x is less than 3. Now I have to figure out, hold on, I forgot something. Darn it. Okay, there's also a 4 on the bottom. Whoops. Right, this 4 here. So that means my answer here should have been 1/4 times x minus 2, which means I would have to multiply the 1's here by 4. So negative 4 to 4. And then when I add 2, let's see, that become negative 2 to 6. Whoops. So because I left off that 4, made a big difference here. Because now when I do Bobo-Botten with the n's, I would get 1/4. So that's where this 1/4 comes from. Okay. So now I need to figure out if the 2 and the 6 are included. So let's just think about this. If I plugged in the 2 for x, 2 minus 2, on the top, I would get, oh, sorry, not 2, negative 2. Sorry. Trying to find my work. Okay, so I might need to do this on a separate sheet of paper. So to check the endpoints here, if the negative 2 and the 6 are included. Okay, so if I plug in the negative 2 for x, I would get negative 4 to the n plus 1 over n plus 1. So it'd be negative 4 like this, times 4 to the n plus 1. Okay. Which would be the same thing as negative 1 to the n plus 1 times 4 to the n plus 1 all over n plus 1 times 4 to the n plus 1. So I just separated the negative 4. I changed it to negative 1 and a 4. Now these 4 to the n plus 1s can cancel. So really I'm getting this series negative 1 to the n plus 1, so it's alternating, and then times 1 over n plus 1. So it's an alternating series. So by the alternating series test, it says if you have an alternating series and the terms of the part that's not alternating, the terms here go to 0 and they're decreasing and positive, yes, 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 then it converges. So that means this -2 here, that's going to be included. So it's less than or equal to. Now let's try it with the 6. So if I plug in the 6 for x right up here, 6 minus 2 is 4. So I have 4 to the n plus 1. On the bottom, I would have n plus 1 times 4 to the n plus 1. The 4 to the n plus 1's canceled. So I just have the sum from n equals 0 to infinity of 1 over n plus 1. Well, I believe we can, because we know the series 1 over n diverges, there's no reason why this series 1 over n plus 1 should be any different. So, yeah. So sorry, I was thinking about how to actually prove that. But we can just say this diverges by comparison to the series 1 over n. Technically, you might have to do like the limit comparison test, but I'm confident in saying that that diverges. Okay, so we have -2 to 6 with the -2 included, and the radius of convergence then would be half the distance across. Well, from -2 to 6 is 8 units, so that means the radius of convergence is 4. Okay, and then there's one more, number 4, which, wow, I'm really running out of room here. So I'm just going to go ahead and do number 4 on a separate sheet of paper. So it's -1 to the n plus 1 times x to the n over 4 to the n. So using the ratio test, I'm going to do the limit as n goes to infinity of absolute value, a sub n plus 1, so -1. So instead of n plus 1, that becomes n plus 2. And then x to the n plus 1 over 4 to the n plus 1 divided by the original. So I'm just going to go ahead and flip and multiply by the original. Yes? You can go lay on the couch. Do you want to? Okay. Over -1 to the n plus 1, x to the n. Okay. I'm sorry, these shadows are terrible tonight. Okay. Just go ahead and cover all that up. Okay. So let's go ahead and kind of break apart this first fraction. So the -1 to the n plus 2 becomes -1 to the n times -1 squared. And then this x to the n plus 1 becomes x to the n times x. And on the bottom, the 4 to the n plus 1 becomes 4 to the n times 4. And then over here, we just have the 4 to the n over, just going to rewrite that, -1 to the n, -1 to the first, x to the n. Okay. So the 4 to the n's cancel, the x to the n's cancel, the -1 to the n's cancel, and then this -1 squared, that's just 1. I'm just going to cancel that out also. So I'm only left with limit as n goes to infinity of the absolute value of x. On the top, that's all I have. On the bottom, I have a -1 and a 4, so over -4. All right. So the absolute value of -x over 4. So the limit as n goes to infinity, there is no n. So this is just going to equal the absolute value of x over 4. I'm going to get rid of the negative just because since we're taking the absolute value and this whole thing is negative, it would end up becoming positive. So it's not necessary to leave that there. And I know this has to be less than 1 in order for it to converge. So I'm going to put the x over 4 in between -1 and 1. That's how you get rid of the absolute values in an inequality. Multiply everything by 4. Okay. Then I just need to test my endpoints, the 4 and the -4. So to test the -4, I would have, so at x equals -4. Okay, I would have the sum of -1 to the n plus 1 times -4 to the n plus 1. Or sorry, just to the n. All over 4 to the n. Okay, so let's see. That's the same thing as the sum of like -1 to the n times -1 to the first times -1 to the n times 4 to the n over 4 to the n. So I just broke apart this -4 as the -1 times the 4 here. So the 4 to the n's cancel. And this -1 to the n times -1 to the n is actually just going to be, so it would be like, it'd be like -1 to the 2n. Okay, which means -1 squared, which is +1, and 1 to the n is just 1. So this thing here, this just equals 1. So literally we just end up with the sum of -1 forever. So if we add -1 to itself forever, we're just going to get negative infinity. So this diverges, which just means that -4 is not included in our interval. So let's check +4. So we would have the sum of -1 to the n plus 1 times 4 to the n over 4 to the n. So we just get the sum of -1 to the n plus 1, which literally forever is just -1, 1, -1, 1, -1, 1, -1, 1. If we keep adding those up forever, it's going to keep going back and forth forever. So this diverges as well. So neither endpoint is included. So we're going -4 to 4 for the interval, which means the radius of convergence would be 4. Okay, so that is the page 9 convergence stuff. And then I'm also going to post the key to the worksheet so that you can really get good at the convergence. And don't forget, I have already posted the first pages of notes on Taylor and Maclaurin series. And I'm getting ready to make a video for the second day of notes on Taylor Maclaurin series and polynomials, which is where the series stuff really gets fun and interesting and exciting. So I hope you're watching these videos and staying caught up, and I'm excited to get back to work and get back to school hopefully very soon. Thank you.